we are just discussing about very important concept regarding the aromatic electrophilic substitution reactions, just orientation and reactivity. Actually, suppose there is a monosubstituted benzene, then at what position electrophile should be attacked? That is called orientation. And what's about the reactivity? That means what is the influence of that substituent? What is the influence of group which is present, which is already present on that aromatic ring? Now, what is the nature of monosubstituted benzene? On that basis, we have studied orientation as well as reactivity of that monosubstituted benzene towards electrophilic substitution. Now, let us see second mode, just explanation based on the Arenium ion intermediate. Now, let us see first category, ortho and para-directing groups with activation. Now, in that category, again, there are two subclasses. One is the group which having plus M effect, group which having electron donating mesomeric effect, and second is the group having plus I effect. Alkyl groups having plus I effect, electron donating inductive effect. Now, let us see first about the electron donating mesomeric effect. We know that in the electrophilic substitution, suppose electrophile attacks on the aromatic ring. What happens? There is a formation of intermediate, and that intermediate is called Arenium ion intermediate, or it is also known as the cyclic carbocation. And this intermediate is resonance stabilized, means it shows the resonance effect. It shows the number of canonical structure and it becomes stable. Okay, this is the general statement. Now let us see which groups are having plus M effect. For example, OH, then OR, NH2, NHR, NR2, SH, etc. They having lone pair of electron on oxygen, sulfur, or nitrogen, and they show the plus M effect. What happens when electrophile attack on the monosubstituted benzene, and how we get Arenium ion? We will see one by one. Suppose attack of electrophile is at ortho position, at para position, and at meta position. First, what happens when electrophile attacks at ortho position? पहिल्यांदा आपण first step बघूया. Consider the example of aromatic compound. Here OH group, there is OH group which having plus M effect. We know that in the phenol, OH having a lone pair of electrons, and it can donate this electron pair towards benzene ring, means there is a plus M effect. Suppose electrophile attacks at ortho position. Actually, how that attack takes place? Here, there is a pi bond. There is a pi bond. This pi bond undergo breaking. One of the pi bond in the aromatic ring, it undergo breaking, and there is a formation of new bond between ortho position and electrophile. There is a formation of new bond between this ortho carbon and electrophile, and we get the intermediate. Suppose this is the new bond between ortho carbon and electrophile. This carbon acquire positive charge, and we get the intermediate, and this is the Arenium ion intermediate. Now this intermediate further undergo delocalization. It undergo resonance effect. Now how it undergo delocalization? This carbon having positive charge. There is a positive charge, means it is electron deficient. Therefore, what happens? This pi bonded electron pair, ही जी pi bonded electron pair आहे, it goes towards that electron deficient carbon. ही या ठिकाणी delocalize होते. It goes towards that electron deficient carbon, and there is a formation of new pi bond between these two carbon. Now, what's about this carbon? या carbon वर कसा charge येईल? Now, this carbon acquire positive charge. It acquires positive charge, and we get the another canonical structure for this Arenium ion. We get another canonical structure. Now there is a positive charge, means again it is electron deficient. Therefore, next pi bond shifted towards it. हा pi bond इकडे shift होतो, and there is a formation of new intermediate. This is new resonating structure. And नवीन resonating structure असेल. While this carbon now acquire positive charge. Here there is a positive charge. Okay. Now there is one more possibility. Here, to the conjugated system, to the benzene ring, there is a OH group. And we know that OH having lone pair of electron, and that OH shows the plus M effect, and therefore it donates its electron pair towards that electron deficient carbon. OH also donates its electron pair towards that electron deficient carbon, and we get the one more canonical structure. Here now oxygen acquires positive charge. It donates electron pair, and that oxygen acquires positive charge. Okay, this is just about the how the delocalization is observed, how the resonance effect is observed in Arenium ion. Okay, electrophile attacks on the phenol. Electrophile attacks on the phenol at ortho position. We get the Arenium ion and which undergo delocalization, which show the resonance effect, and we get number of canonical structures, and these are the canonical structures of Arenium ion when it is formed after attack at ortho position. Okay, now here this last structure, I will call him as a S. That last structure is the S. S means it is especially and having additional stability. That structure is having additional stability. Now, why it is additional stability? Why it is especially stable structure? Now, in this resonating structure, all the carbon atoms as well as oxygen having complete octet of electron. What's about this carbocation? What's about this resonating structure? Here, positive charge is on the carbon. Positive charge is on the carbon. Means that carbon is having only 6 electron in its valence shell, means its octet is not complete. Again here, this carbon having positive charge means there are only 6 electron in its valence shell. It do not having complete octet. Here also, it do not having complete octet. Means remaining 3 resonating structure do not having complete octet of carbon. Therefore, comparatively, they are unstable. But this last structure, हे जे शेवटचं स्ट्रक्चर आहे, याला आपण यस असं म्हटलेलं आहे. That last structure, that resonating structure having additional stability, I can say it is especially stable structure. Why it is especially stable? Because all the carbon atom and oxygen having complete octet. Okay, this is the attack of electrophile at ortho position. Now let us see what happens when attack of electrophile takes place at para position. I will take the same example of phenol. Suppose phenol comes in contact with the electrophile. Then suppose it attacks at the para position. This pi bond undergo breaking and there is a formation of new bond between this para position and electrophile. Now what's about the second carbon of aromatic ring? Now it acquires positive charge and we get the intermediate carbocation, which is also called Arenium ion. Now this Arenium ion is also resonance stabilized. It also shows the resonance effect. It also undergo delocalization. Now how the delocalization is possible? Now this carbon is electron deficient. It having positive charge. Therefore, this pi bonded electron pair goes towards electron deficient carbon. He electron pair ikade jate. It goes towards electron deficient carbon. Means there is a formation of new pi bond here. It's a navin pi bond tayar hoto. Okay, this is the new pi bond. Here, this is the new pi bond. Okay, now this carbon acquire positive charge. आता या carbon वरती positive charge आहे. Okay, now there is one more possibility. Here, oxygen having lone pair of electron. OH group shows plus M effect. Therefore, it donates this electron pair towards that ring and there is a formation of pi bond. त्यामुळे इथं pi bond या ठिकाणी तयार होतो and thus there is a formation of pi bond. मग इथं pi bond तयार होतोय. ठीक आहे. Now that oxygen acquire positive charge and this is the new pi bond. Now there is one more possibility. यामध्ये आणखीन कुठली possibility आहे का? Yes. This electron pair goes here. ही electron pair इथं जाते. त्यामुळे पुन्हा pi bond मधली electron pair oxygen कडे जाते. While this carbon now acquire positive charge. या carbon कडे आता positive charge येतोय. Here there is a positive charge and we get one more canonical structure for Arenium ion. Thus, similar to the first one, पहिल्यांदा जे आपण बघितलं, attack takes place at ortho position and this is the attack takes place at para position. In the case of para position, electrophile attack on the phenol at para position, we get Arenium ion and this is also shows the resonance effect. It undergo delocalization and we get number of canonical structure. What's about the additional stability? यामधलं कुठलं structure आहे का which having additional stability? This structure number third, it having additional stability. Why it having additional stability? Because all the carbon atoms and oxygen having complete octet. Thus, in the case of para position, we get again especially or additionally stable Arenium ion. This is about the attack at para position. Now let us see third possibility. Suppose electrophile attacks at the meta position in the same case. We will take again the same example, phenol. Now when this phenol comes in contact with the electrophile, and suppose this electrophile attacks at the meta position. Now what happens? This bond again undergo breaking, pi bond undergo breaking. There is a formation of new bond between this meta position and electrophile. We get the intermediate. This is the new bond between meta position and electrophile. While this carbon already having hydrogen, I have shown that hydrogen. What's about the another carbon? Another carbon जो आहे, yes, it should be acquire positive charge, and we get the intermediate carbocation किंवा आपण त्याला Arenium ion intermediate असे म्हणतो. And thus, and that Arenium ion again undergo delocalization. It having positive charge means electron deficient carbon. Therefore, this pi bond shifted towards that electron deficient carbon, and it form a pi bond between that two carbon. इथं नवीन pi bond तयार होतो, and we get the another canonical structure. This is the pi bond here. Actually, sorry, there is a electrophile here. There is electrophile. I was forgot to show and hydrogen. Okay, and that carbon having positive charge. Okay, this is the possibility. This is the possibility. And next canonical structure. Now this carbon having positive charge, and therefore this pi bonded electron pair shifted towards that electron deficient carbon, and we get one more resonating structure for the Arenium ion. And this is the resonating structure. This is the new pi bond. इथं नवीन pi bond तयार होतो, while that next carbon acquire positive charge. Here this is the positive charge, and thus similar to the ortho and para. In the case of meta attack, here also Arenium ion undergo delocalization, and we get the number of resonating structure. But what's about the additional stability? Is it any resonating structure having additional stability? No, because in the case of that three resonating structure, they are having positive charge on the carbon. Therefore, their octet is not complete octet. Hence, it do not having a special stability, just like ortho and para attack. Suppose this is the first case. When attack takes place at ortho position, electrophile attacks at ortho position. Suppose attack takes place at para position, we get again Arenium ion. Third case is the attack takes place at meta position. We are going to discuss comparative stability of Arenium ion among ortho, para and meta attack. या तिन्ही केस मध्ये कोणता Arenium ion हा लेस स्टेबल किंवा कुठल्या Arenium ion मोर स्टेबल आहे. Now, what's about the stability? What's about the stability? We know that if any species shows resonance effect, then that species are more stable. We know that more is the number of canonical structure, more is the stability. More is the number of canonical structure, more is the stability. What happens in the case of ortho attack? There are 4 resonating structure. In the case of para, there are 4 resonating structure. But in the case of meta, there are only 3 resonating structure. Hence, on that basis, we can say that Arenium ion in the case of meta attack is less stable. This is the first reason. हे झालं पहिलं reason. त्यानंतर second reason काय सांगता येईल? In the case of ortho attack, we get the additional stable, especially stable resonating structure, because in that structure, all the carbon and oxygen having complete octet. Therefore, this is spatially stable. While in the case of para attack also, this structure is having additional stability, because here also there are all the carbons and oxygen having complete octet. But such a stable structure, that especially stable structure, is not possible in the case of meta attack. And therefore, from that we can conclude that here the Arenium ion, which is formed after ortho and para attack, is more stable than the meta attack. मी पुन्हा एकदा रिवाइज करतो. The Arenium ion intermediate formed after attack at ortho and para position, they are more stable than the intermediate which are formed at meta attack. This is due to the following reason. दोन reason मुळे या ठिकाणी हा stability आपण explain करतोय. First, at ortho and para position, there are 4 resonating structure, while at meta position, there are 3 resonating structure. This is the first reason. Second reason काय आहे? The resonating structure, yes. The resonating structure, yes. For ortho and para attack, it having additional and spatial stability. but it is not in case of meta attack. And therefore, in this case, electrophile attack on the aromatic ring at ortho and para position to form more stable Arenium ion. म्हणून काय होतं, इलेक्ट्रोफाईलचा अटॅक कुठे होतो, ऑर्थो किंवा पॅरा पोझिशनला, टू फॉर्म मोर स्टेबल अरेनियम आयन. लक्षात ठेवा, ड्युरिंग एनी केमिकल प्रोसेस, suppose product is more stable, then the formation of that product becomes easy. And hence, in the case, या सुद्धा केस मध्ये काय होतं, electrophile attacks at ortho and para position to form more stable Arenium ion than the meta position, and thus that groups are, that means the group which having plus M effect, they are ortho and para directing. Okay, this is just about the plus M effect. Now let us see, suppose there is a plus I effect, what happens? For example, alkyl group. Let us say example, I will take example of alkyl group. Suppose there is a methyl group attached to the aromatic ring. Then what happens? When that methyl group is attached to the aromatic ring, it having plus I effect. Electron donating inductive effect is there. Suppose this is the electron donating inductive effect. Now let us see what happens when electrophile attacks on that toluene. Suppose attack takes place at ortho position, that pi bond undergo breaking, and there is a formation of new bond between that ortho position and electrophile, and we get the intermediate. Now that second carbon acquires positive charge, and this is the Arenium ion. It again undergo delocalization. This electron pair goes here, and there is a formation of new resonating structure. Here that carbon acquires positive charge, and we get the another resonating structure for Arenium ion. Now this again undergo delocalization. This pi bonded electron pair shifted towards electron deficient carbon, and there is a formation of one more canonical structure. Here, what's about this carbon? Yes, now this carbon acquires positive charge. There is a positive charge, and thus similar to the phenol, when electrophile attacks on the toluene at ortho position, we get the Arenium ion, and this Arenium ion is the resonance stabilizer. It undergo delocalization, we get number of canonical structure. Now what's about the stability of that canonical structure? Here I must say that last canonical structure is the more stable. It having a special stability, additional stability. Why it is special, having special stability? Because that carbon which having positive charge, and alkyl group is attached to that positively charged carbon. Electron donating group is attached to positively charged carbon. Therefore, it is more stable. Alkyl group, electron donating group, is attached to the electron deficient carbon. Electron donating group is attached to positively charged carbon. Therefore, it is more stable. It having additional stability. There is one more reason. त्यामध्ये आणखीन एक reason आहे. And due to that reason, it is again more stable. But that carbocation is a tertiary in nature. This last carbocation is tertiary. What's about the first one? First one, this is the secondary carbocation. This is also secondary carbocation. While last one is the tertiary one. And we know that tertiary carbocations are more stable than secondary. And thus, that last carbocation is again having additional stability. Okay, now let us see attack at para position. Upon second possibility बघूया. Suppose electrophile attack on the toluene at para position. या position ला again same type. Here this pi bond undergo breaking. या bond चं breaking होतं. There is a formation of new bond between para position and electrophile. This position already having hydrogen. I have shown that hydrogen. While this second carbon acquires positive charge. Here there is a positive charge on the second carbon. Now this Arenium ion, this carbocation again undergo delocalization. This electron pair goes here. There is a formation of pi bond. While this carbon acquires positive charge, it's a positive charge here. Yes, there is a positive charge here. Okay, now it again undergo delocalization. Ha pi bond इथं shift होतो. While this carbon now acquire positive charge, and we get last resonating structure for that Arenium ion. Okay, here there is positive charge, and this here also delocalization of electron is there. And due to that delocalization, that Arenium ion shows number of resonating structure. Now, what's about the spatial stability? That second one. Why? Because electron donating group, the group which having plus I, it is attached to the positively charged carbon. Therefore, there is additional stability. Also, that Carbocation is a tertiary, therefore it is more stable, and thus this is the second possibility. Now let us see third possibility, meta position. Again, example is the same, toluene, that methyl group having plus I effect, there is electron donating inductive effect, and suppose that electrophile attack at the meta position. Now what happens? There is a breaking of pi bond and formation of new bond between meta position and electrophile. Okay, this is the new bond between meta position and electrophile, while another carbon acquire positive charge, and we get the Arenium ion. Again undergo delocalization. Here this pi bond shift between two carbon. It acquires positive charge. We get the resonating structure. Here there is a positive charge. Again undergo delocalization, and there is the formation of one more canonical structure. Here there is a positive charge. And in that case also, Arenium ion undergo delocalization, and we get number of canonical structure. We get number of resonating structure. What's about the additional stability? Is it having any additional stability? No. There is no any tertiary carbocation. In the case of meta attack, there is no any tertiary carbocation, and also that electron donating group is not attached to the positively charged carbon. Therefore, that Arenium ion do not having additional stability. Now let us see just comparison. I will show the comparison, directly comparison between different Arenium ions when attack takes place at ortho, para, and meta position. Suppose this is the first case when electrophile attacks on the toluene at ortho position, we get different Arenium ions. These are the resonating structure. Second, suppose the electrophile attack in the para position, we get again Arenium ion, which is resonance stabilized. Third case, suppose the electrophile attacks at the meta position, again there is formation of Arenium ion, which is also resonance stabilized. This in the all three cases, there is a formation of Arenium ion, and they show the resonance effect. But what's about the stability among them? त्यामध्ये कोणता more stable आहे? In the case of ortho and para attack, ortho and para attack मध्ये, we are having additionally stable Arenium ion. This is additionally stable Arenium ion. Why they are additionally stable? Because electron donating group, methyl group, is attached to positively charged carbon. Also, there is one more reason also, that carbocation is a tertiary in nature. It is tertiary in nature, and therefore, as compared to other, this canonical structure are stable. But that additionally stable Arenium ion, that additionally stable resonating structure is not possible for meta attack. And the resonating structure, yes, of Arenium ion intermediate formed by attack at ortho and para position, it having especially more stability, means it having additional stability, because electron donating group is attached to the positively charged carbon. Also, resonating structure, yes, it is tertiary carbocation, hence it is more stable than remaining secondary carbocation. But that stable resonating structure is not possible when electrophile attack on the meta position. Therefore, electrophile attacks on the toluene at ortho and para position to form more stable Arenium ion. And therefore, that alkyl group, that methyl group, they are ortho and para directing. Okay, we have studied actually how the attack takes place at that different position in the case of electrophile. आणि मग त्या ठिकाणी ऑर्थो आणि पॅरावरती अटॅक झाला तर त्यामध्ये आपण दोन एक्झाम्पल्स पाहिलेले आहेत. वन प्लस एम इफेक्ट असेल तर कसा होतो, आणि दुसरा प्लस आय इफेक्ट असेल तर त्या ठिकाणी ऑर्थो आणि पोझिशनला का होतो. ऑन द बेसिस ऑफ Arenium ion intermediate आपण स्टडी केलेला आहे.